Welcome to section 2.1. We're going to be talking about the addition property of equality. So we are going to start solving equations. But first, let's talk about some definitions here. There's a difference between an expression and an equation. Expressions have no equal sign in them, and you will be asked to simplify them. You're not going to end up with x equals 5 at the end. You'll end up with something maybe like 3x plus 7. It's simplified. You can't figure out what x equals to. If we do have an equal sign in it, then it is called an equation. Equals equation tells you right there. And you'll be asked to solve it. And if you're asked to solve it, that's when you're going to end up with x equals a number. You'll start off with an equal sign in the problem. We'll move things around. We'll be able to say, well, x must equal 2 at the end of it. Okay. Now, what we're mainly going to be worried about, we're going to be solving linear equations in one variable. I am not going to shy away from giving you official definitions in this class. I will always explain them, but the more you are exposed to formal definitions, the better off you're going to be overall. A linear equation in one variable is something that can be written something like this. ax plus b equals c. A, b, and c are just some numbers in there. X is our variable. Now, why is it called linear? Because when we get to where we are graphing these in another chapter, when we graph them, they always make straight lines. Now, what we are looking for mainly is that we just have one variable, obviously one variable, just an x, not an x and a y, not a t and an s, just one variable. And we don't have a square or a cube or a fourth power, anything else like that on our variable, just plain x. And we have a linear equation in one variable. Okay. Now, the addition property of equality, and this is also true for subtraction. In math, a lot of times we have addition and subtraction rules, and we have multiplication and division rules, and we have to learn how to keep them separate. And often they work together. So we have a rule for addition, we also have one for subtraction here. What this says is if we start off with something that is equal, if a equals b, then we can add the same number to both sides, see it's c on both sides, and we still have something that is true. So we can add or subtract the same number from both sides of an equation and still end up with something that is true. Okay? So this is the main property we're going to be using in this section. We also need one other little property here. And why this property works will be a lot more clear after we get through section 2.2. But for right now, and the way we generally use it, it's just like this. If we are solving an equation, and instead of ending up with x equals 3, we end up with negative x equals 3, where a is just some number here. The way we solve for x instead of negative x is we just change the sign on both sides. So, for example, if I have negative x equal to 11, I want to find x equals something, but I've got negative x equal to. This property says all I have to do is I switch the signs on both sides. So instead of negative x, I write x. Instead of positive 11, I write negative 11. So your answer to this equation is negative 11. X equals negative 11. Okay. So now that we have that property, let's try working a couple of other problems. Now, what we want to do first is we always want to treat it like we have two problems, one on each side of the equal sign. And we want to simplify them as much as possible. Now, remember what we mean when we say simplify. That means combining like terms. It means distributing. It means making each side as nice and neat as we possibly can. This one is already simplified on each side for us because I'm not allowed to combine these two because they aren't like terms. And you can't get any simpler than negative 8. So once you have each side simple, what we're going to do is we start to undo things. think about it this way. If I add 2 to something and I want to undo that, I subtract 2. Addition and subtraction go backwards. They undo each other. Okay? Now this is saying somebody, there's this number that I don't know about, and somebody subtracted 5 from it, and once they did that, I got -8 as the answer. And now we're trying to figure out what this original number was. This is always just like reverse order of operations. The last thing that happened to this mystery number was it was subtracted 5 from it. So to undo that, I add 5. What you do to one side, you also have to do to the other side. Now, we often say that we're moving it, and I usually draw an arrow showing I've moved this from one side to the other. Whenever you move across the equal sign, that's when you're going to use the opposite sign. Okay? Well, I'm going to write out every step here, but there's a step that you normally would not end up writing. And we would normally say that -5 and +5 cancel each other out. But really, what's happening there? -5 plus 5 is 0. So I have x plus 0 equal to -8 plus 5. We have opposite signs, so we're subtracting. That would be a 3. The 8 had the larger absolute value and was negative, so the answer is negative. Okay, so that's -3. Well, what do we get when we add 0 to something? It doesn't change, right? So this is just still x equals -3. And that would be your final answer. Now, how would you check this? We take what we think our answer is and we plug it in for our x. And if we've got it correct, we should end up with the same number on both sides once we simplify. So this would be -3 minus 5, and we hope it equals -8. Well, this is -3 plus -5. And they're both negative, so we add them together and get 8. Since they are the same sign, we keep the sign. Since they're both negative, our answer is negative, and we get -8 equals -8, which is true. So that means this was our correct answer.